So welcome to week 4 of CO232. Let me go ahead and log into the system that we will use for our demos. This is our second week talking about file systems. Okay? File systems are very important because they provide the foundation for the operating system. So a well-managed file system typically means a well-behaved operating system. The most common problems on an operating system in the environment, basically, are due to file systems filling up, files having wrong permissions, files disappearing for whatever reason, our inability to find files. All those are important issues that we want to talk about. So based on last week, does anybody remember the different types of files that we can have on a Linux system? What types of files can we have? Okay, yeah, text and binary files, very good. Any other ones? Executable, yep, so it's a binary file with some security set on it, yep. Any other ones? Please. Okay, we can have links, excellent, symbolic links, hard links, yep. Any other ones? Directories, yeah, a type of a file. How about the files under the DEV file system, under the folder or directory DEV? What's that? Special files, yep. Device files, yeah, device files. So you connect a new device, and then under DEV there's going to be a reference for it. Device files, and then there were some oddball files that, we don't use as often. Remember the sockets and the named pipes, which are really core of the back end. So the administrators don't work with them as often. All right. So we have plenty of files, plenty of tools to look at files. The big thing today that I want to go over is going to be the security on files themselves. Okay? And so that can be a little bit tricky, especially when we get to the special permissions. So that's going to be the core of what we want to learn or review today. Before we get to that, though, let's talk about the file system hierarchy standard, okay, the FHS. If you think about having a lot of Unix systems, even in the old days, your AIX, your HPUX, Solaris, but especially now when there's so many distributions, standards is what saves us. A standard is basically something that we agree on as a community, and we sort of promise that we will obey this. So a standard in open source Linux community is the system of directories that we have present on a Unix-like operating system. And these directories have special names that we stick to. Just think about it. If you have a program that you are writing, you would want to rely on some directories being present. Okay? On Windows, maybe that's C Windows. And so you know what's inside of C Windows, and then under C Windows you have C Windows System, System 32, and you have sort of expectation of what's there. By the way, what's the file that manages DNS resolution on Windows? Like if you wanted to www.google.com point to www.yahoo.com, just as a joke, all right? What file would you change? Please. And where is that at? Yeah, so it's under C Windows, System 32 drivers, and there's an etc folder, which reminds me of the etc folder we have in Unix, and then host. And and there is a host file on our system under etc hosts. And this whole agreement and the standard is not so much even for software developers, because in most Linux software you can say a prefix. A prefix means install me into this directory, and you can choose whatever directory. It's really for the sanity of the administrators. Okay, as you go from this Linux system to this Linux system, you don't have to relearn the whole thing. So under the standard, which by the way is in the textbook on page 141, under the standard, these directories have some definition to them. Okay, for example, the bin directory, the BIN, stands for binary. It really should be more like executable, right? But it's bin, and it's a common name for a directory in many places. Basically, as you compile a software, there's going to be a CONF, a configuration directory, and bin for what's compiled for the running programs. So that's what /bin means. And you can see that the key programs here, for example, is CAT for cat. There's the CP command in here. So this is where the programs reside, right? You can, if you're the root user, you can go in and rename CP for cat and the other way around, right? It would cause a mess because you try to say CP and it ends up doing something else. But that's all it is. It's under /bin, and we have these directories. If I was to go under user, there's a bin directory, and often under local there's another bin directory. Okay, so bin simply means it's a binary repository of binary files, most often executables, and so we have this first. That's what is in the first directory. Then we have boot, and boot is of course used when the system starts up, and it's a file system that the kernel is stored on, which is why when we created our systems, we created a new partition for it. So that way, in the process of booting, which we're going to discuss in the future, you only have to mount that partition, and then you mount the file system to the root position from a different partition. Okay, so that's why boot would normally, preferably, be a separate partition all by itself. But boot inside will have things like grub, and grub happens to be the bootloader that we're using, the bootloader. And whenever you see lost and found, it means it's a separate partition, lost and found. Why is it used? Well, sometimes, for whatever reason, when there's a crash on the system or files get discombobulated for whatever reason, files that are present but are not in the right directories, or maybe their names somehow got corrupted, they will be in the lost and found. Okay, so that's per partition there's a directory like that. Okay, other than that, we have the DEV for devices, ETC for most configuration. So if you were to maybe try to configure the Apache web server, you would go under ETC, HTTPD, CONF, and then that's the main configuration file. So if there is software that, as the administrator, you're thinking, I need to change a setting, you automatically would go under ETC and start looking for that software, because that's what the configuration is. So in some ways, ETC is like the registry on Windows, because on Windows, to change behavior, you often go to the registry, and you would do that under ETC for whatever program that you're thinking about. So ETC has configuration for programs that are compiled as part of the operating system. Okay, I can have Apache installed as a separate program which I installed and compiled. In that case, it will be under user local Apache. And then the configuration file will be in that directory, well, under CONF. But if you use yum to install software, so you install software as a package, then that configuration will be under ETC. All right, so that's why you would see configuration under ETC. Excellent. Other than that, we have home, and home is the directory where users, non-privileged users, so non-root users, would have their personal files. Now, personal files is deceiving because in most companies, none of the files are personal. If you think you can hide something or that you own something, you're wrong, right? So this is called home because it stores things like settings. You open Firefox and all your settings are stored in the home directory. When you resize a window and you close the window, it's going to store these settings in home. So if you would like to copy all your customizations to a different Linux system, you can copy the home directory, and it'll have all the aliases that you've created, all the little things that you like to preserve and have. So that's a home directory, and the more users you have on the system, the more home directories will be created here. Okay, then we have lib, which basically stands for library. Okay, so if you are a system developer, you're developing a new program, you can use lib to link in to dependencies. Okay, and then you can use modules that others have created. Media is sort of a wild directory. If you plug in, if you put in a DVD-ROM or CD-ROM, it goes into media. It used to be called /DVD, okay? But if you had a CD, it also was mounted there. So they just called it media in the last few releases of Fedora. And oftentimes, if you plug in a USB drive, the physical representation of it will be in media. Now, under dev, it still has its low-level device name, but its folder, what we can operate with and where we can place files, will be under media typically. So that's media. There's also MNT folder, and in the past, this was used to mount a CD or DVD, so it was MNT. And I think the reason why it isn't is because MNT is a very non-descriptive, basically half a word. So it stands for mount, and mount really makes sense only for Unix users. So now that we want more and more workstations to be part of the Linux community, we try not to use these cryptic names. So media makes more sense. It's something you plug in, something that is going to, you can work with. So this directory is empty, and if we have other devices, just like under media, we can mount them or create their physical representation, a folder under mount. Okay, other ones, the OPT. OPT is heavily used on all Unixes. So if you have Solaris, you have HPUX, most of your software is under OPT. Stands for optional. So you have programs, they would be here. Not used very often on Linux distributions though. Root is the home directory for the root user. Everybody else goes under /home. Root is special. Okay, root is special for multiple reasons. Oftentimes you may mount the home directory on a remote system. So the administrator for maintenance needs to be able to log in and operate before everything else is mounted. So it's nice to have the root home directory somewhere else. So far, what things do we call root? What other things do we call root on the system? Okay, the administrator user, super user is root. Yep. Then we have this, which is, right, because this is not the user. This is the home directory for the user, and it's actually spelled out root, which is which is nice. And then there's one more root. One more root would be the slash that we use on the file system. So if I do pwd, this slash right here, it's the root of the file system. Okay, so again, root can be used as multiple things. Okay, so that's root. SBIN has also programs, but these programs are for the super user to use. Okay, these programs most of the time have special meaning to the operating system. fscheck for checking the consistency of the file system. fdisk for formatting and creating new partitions. I'm sorry, not for formatting, but for creating new partitions. What else do we have here? If down, if config, these are all networking utilities. And we would use if up, if down for turning on and off network interfaces. IW config is for configuring wireless devices. Let's see. ls mod shows us the modules that are in our kernel program. So maybe you've noticed that I showed you a command to log in as root in the past, and there was a dash after that command. Okay, what's the command to log in as root? SU, right? If I just say SU all by itself, it'll work, but the path will not include the sbin folder, the /sbin. Okay, so if you try to say lsmod, it'll say command not found. Okay, but if you say su dash, then you are inheriting the environment for the root user. You're not staying with your own regular user environment. You get the environment, the variables that the root user would have. Therefore, the path statement includes /sbin. So then you say user ed, and it works. You say lsmod, and it finds those special commands that are in the sbin folder. So that's why when we log in as root, most of the time we do want the dash in place. Okay, sbin, SE Linux. We will have time to talk about this. Basically, it's a new and improved a project that was started by a government agency that is supposed to help us to protect the Linux system at a whole new level. Basically, it is a way at the kernel level, okay, to allow new security features like creating the contexts. So for example, you can say through SE Linux, if you log in as the root user through the console, then you can do whatever you want. But if you log in as the root user through SSH, then you can't do anything, which is very helpful because most of the time the way people break into the system is maybe by cracking an Apache vulnerability and then executing commands as the Apache user. So then the context is all wrong. See? So SE Linux allows us all these new security features that previously were not available. Having said that, SE Linux can be a pain to work with because all those security features. So in many installation documentation, it'll say right away, turn off SE Linux and then go to step 1. And they do that because SE Linux is really designed to go on systems that are on the edge of the network. So web servers, maybe if you have proxy systems or application firewalls, those are the systems that are facing, they're standing outside, often even outside of the DMZ, and they are being most likely hit by hackers and so forth. So those have those additional security layers, whereas if you have a database, okay, SE Linux gets in the way because of all the operations that the database will do, and to configure that for most DBAs is just a lot of hassle. And they are in the back anyway, they are behind firewalls, behind all kinds of things, so there is a reasonable security already present. And of course, without SE Linux, you continue to have all the normal Unix security features, so it's not like it's completely exposed. All right, temp would be our file system or folder, that directory that allows us to temporarily write data. And you can, through an environment variable, you can change which temp directory you're using. USR, it's sort of now the OPT file system. So what used to go under OPT goes under USR. We have all kinds of user-managed software and user-managed content, like backgrounds, like icons, things that you might want to use, and it's typically shared. User local is a place where most of the time we would put software that we compile, software that maybe we use on the system. Maybe it's a custom MySQL server, put it under user local MySQL or user local Apache. It's a very safe directory from the operating system. Okay, if you put it in maybe bin, okay, that directory is being heavily monitored and used by the operating system, so something could end up being overwritten at some point, whereas under user local, it's sort of a safe location for your custom software. There was also here our var, and var, it's a very interesting directory because var is it's sort of a mixture, okay? Var has, for example, the log directory, and all the operating system logs are under var log. But it also has www, which is the document root directory for the Apache pre-installed with Fedora. So you can have log files, you can have web server files, you can also have, like under run, many PID files or the process ID files are located under var. And some sockets, like for MySQL, also go under var. So it's a directory where the operating system and the yum installed software is going to often put either temporary data or data that is doesn't fit anywhere else. So we have cache, we have mail, which basically is going to, all the emails that get sent are temporarily stored under mail. Spool, which has, let's see, here's the mail queue, and I'm looking for the place. Oh, it's under cache. So when you download software, you say yum install Firefox. See, yum is going to download that software first under var cache yum, and then from there it goes to install it. Or if when you say yum upgrade, all the software first goes into this cache directory, and then it's executed from here. So it's sort of a wild file system where many different things are going to be put in. Okay, I skipped proc because proc is a very unique directory, and it's not even a real directory. Okay, it's sort of a phantom directory that the kernel creates and maintains. So it's present when the operating system is running, and it's going to have a directory for every process on the system. So when you start a program, there is a directory for it in proc, and in the directory we store the original command that was ran, what elements of the operating system or what resources are being taken up by the process. Any of these numbers right here refer to programs that are currently running. So we have detailed information about the environment that the program is running. We have a copy of the executable. You sort of get a glimpse at what the kernel has to track as the entire operating system is running. Some of the other pieces in this directory are the net or the sys folders, and in these the kernel has its settings, the live settings. So if you want your system not to respond to ping, someone sends a ping command and you want your system just to drop that as if it didn't exist on the network, you would go under the net directory and then change a setting there, and that tells the kernel don't respond to ping. Okay, when you restart the operating system, that setting goes away. Proc gets rebuilt and it'll respond to ping again until you go under etc, okay, under a system information folder, and then you can change that ping setting for the kernel so it sticks. You change it in the config file, right? So now that change doesn't take place until you restart the operating system and the config files are reread. So proc would be somewhere, a place where you can make the changes for immediate visibility, and etc, where the config files are, to stick to basically be an ongoing change. Yes, question?
Would that also be where it's storing all the references to what administrator programs do?
Right. Yeah. So this is you know, where it tracks all the current operations. Yeah. And sometimes when you debug programs, it's useful to go into the PID of the program and then check, you know, what is the environment that it's running with. Most of these are actually text files, and you can open them with a text editor. Yeah, that's helpful. You see, what we can do is I can start. What helps is to actually be root when you do that. So let's do that. So we can go under proc and maybe 836. And so let's look at the environment. You can see the environment this was started with, and then I can see, let's see, there is information about the memory. Was it com? Yeah. So then you have the command that was actually executed, and then the command line. So a lot of information right at your fingertips if you know the program a PID that you're looking for, and of course you can check the PID by just looking up the number right here, and so you can learn details about the running program, what it is that it's doing. It's all out there. You can debug your own system fairly well. Okay, so that's the file system. A nice reference for the Unix file system in the FHS, or the File System Hierarchy Standard. There is a nice article here which basically takes you in more detail through the directories to show what can be expected in those files. Okay, that's what the standard really means. What can you expect as the administrator? No two Linux distributions look the same. Okay, unless you're Red Hat and CentOS, right? Because CentOS basically compiles their source code. But across distributions, actually, they're slightly different. Even the way they will install software, like they'll install Apache, and instead of having etc httpd conf httpd.conf, they'll have 2 or 3 config files that are included from each other. So there's a great flexibility on how software is installed, and they will install it differently, but then they'll have exceptions on what directories they're using. It's a standard, more of a guideline, right? Like in the Pirates movie, more of a guideline. Okay, the FHS, excellent. The FHS is a nice reference. We covered some of the commands last week, but let me ask this: how would you find a file? How would you find a file on the system? So let's say that we are a regular user here. Let me open a new tab. We're a regular user, and I'm looking for a file called my.zip. Okay, let's say I don't know where it is at. What command could I use to find file my.zip? How would you go about doing that? Grep. Okay, so if you just say grep, you will look inside of the files. So grep allows you to look either through standard output, which basically will be text that flows through the screen, or you can look inside of the files in the current directory. So we will use grep in a minute. Yep. But find. Okay. So find is a great command, a find command. Find. It's very annoying though, because it's old, and it means that it has so many different options that you can get lost in them. And I think the textbook actually has a whole page on the find options. It is very granular. You can look for a file which was created in the last 5 days, or a file that was modified in the last 5 days. Maybe a file that was modified at a certain time and has a special extension. The feature of the find command is that it physically walks the file system. It physically walks the file system, which means that what would be a downside of when you look for a file of physically walking through the file system?
A long way to go.
Okay, yeah. So if it's an older file system, or maybe you have a website on the file system with many files, it can take forever. I'll give you an example. This is what the find command does when you search the entire operating system, right? So it goes through every file, and it checks for whatever properties that you're looking for. So you can use with find like a dash name option and then look for a name, okay? Just to show you that it's possible, I can go to, no, let's go back. I can say find, then start at the beginning, and then see the grep command that we mentioned? The grep would go after the find, and now perhaps I'll say show me my.zip. So now the find command goes through the different directories. It already found my home, my.zip, right? Great, found the file. But it goes on to finish its walk through the rest of the directories. And by the way, when I just said /find, it actually takes it very long because it has to display all the files. Okay, that's probably what takes the longest time. But now, with this, I actually have pretty good performance of finding this. But notice all these permission denied messages. That's because I'm a regular user. And because find goes physically through the file system, it says, show me this file, or I want to know about this file. And the operating system, says you don't have permissions. And so that's why it produces those error messages. Another way to find files would be with a locate command. Now, here's the huge difference. The find command basically takes the file system like a book, starts at the beginning, it looks at every page and says, okay, is the file here, is the file here, is the file, and that can take a long time. The locate creates an index of all your files, and when you say, I want to find my.zip, it goes to the back of the book and it says, oh, it's all on such and such page. Huge difference. Now, locate requires a little bit of maintenance. It requires that the database of all your files is maintained. And so there is a command that you run as a root. It's called update db. And this command is scheduled already by your system to run every so often. And as you use commands like copy and move, the database is automatically updated. Sometimes files, though, come about through installation process, or maybe they are somehow automatically created by magic. Okay, and so then the index is not well updated. So that's why update is going to, or update db will nightly run. And so you can execute it, and it executes very quickly because it'll just do incremental check on new files. So I could say locate my.zip, and when I do that very quickly with no errors, I only see the file I was looking for, right? So locate is a really nice feature. Our Explorer window also has a find button. And here we can type in my.zip, and it'll go ahead and, well, you have to specify location, so let's just go with our home location, and so then it just finds my zip in a more graphical way. All right, so that's how we can find files. And I do like the grep method with find, because sometimes you may not be looking for my.zip. Maybe you are looking for a file that is very common in name. Trying to think of a file that's very common. Maybe bin, right? You're looking for the bin directory. We saw it all over the place. So with the grep command, you can specify a pattern. I want bin that includes the word home, that includes the word WebLogic, and then I won't see that bin. And so then find would be nice because it allows you to customize, what it is you're looking for, in more than one way. So just a toolbox that we have, and we choose the right tool for the right time. Great. So that is how we find files. So let's move into this main issue of the day, which is permissions. There are a few ways of setting permissions. There is the geek way. There's the geek that's sort of warming up to change. And then there is the graphical user interface way. if you right-click on any file, you can go to Properties, Permissions, and right from here, you see, you can set permissions for your file. Okay. You still have to know what the permissions actually do, and we'll talk about that. But I want to let you know right away that there is a way to set permissions without, having to memorize a lot of geek speech. But before we can use really those easy tools, let's talk about some of these permissions and what they do. So on a file and on a directory, you can have at least 9 traditional permissions set. These 9 permissions, because the first column is the type of the file. So D is for a directory and a dash is just for a regular file. The first 3 apply to the owner of the file. When you create a file, you are the owner of the file. Okay? And so the owner of the file is the first column. Then there is the group that the file is associated with. When you create a file, oftentimes the user and the group are identical, because when you create a new user, the default on the operating system is to automatically create a group with that user name. So it helps us to quickly create users, and then if you would like to create a default group for this user that's different, you can go ahead and make that change. There's a user modify command that allows you to do that. But it's very common to see the same user and name of the group to be identical. It's important to note that the root user, as you see it with the file new, the root user is different than the group root. If your username is root, you are the super administrator. You can do all kinds of things. If you are a part of the root group, you can do very few things. The root group does not have automatically the same rights as the root user. Okay? Because most files have different settings for the owner and for the group. So the group called root is not a whole group is not user administrators. Okay, so the first 3 are the owner, then the group, and then the other 3 is everybody else on the system, any other user that's present. So oftentimes the first 3 would be represented by letter U for user, the next 3 letter G for group, and the next 3 O for other. Okay, and that's important because if you would like to remove the read permissions for the others on the file my.zip, you can use this simple command. You can say chmod or change mode. It's the core command for changing security settings on files. Chmod, and then you say O for others minus R on my.zip. Okay, so I can now see that the R was removed. So I said chmod O minus R. What do you think is the command to add those rights back, if you want everyone else now to read it? There you go. I love this set of commands because they are logical. They're intuitive. Okay, unlike the ones that we're going to talk about next. Okay, so this is intuitive. So here is the other feature of this syntax that is unique and great. I can say chmod minus R recursively, which means that in the current directory and all the other directories there, hundreds of files, I can simply subtract the read rights from everyone else. I am not modifying any other permission on that file. Other ways and syntax of this command would require me that I specify the user, the group, and the other permission, and then I can do it recursively. But then I'm going to change every file to those new settings. Whereas with the minus and the plus, syntax, I can just change that permission on whatever the other existing permissions are. So this is a very powerful syntax, intuitive, and allows for a little bit less error, especially for folks that are not doing this every day. Okay, here is how this would now work. You can say u minus r, and so I just took the read access away from the owner of the file. Okay, and further I can say go ahead and subtract also the executable rights. So the three types of rights we have here is the read, the write, and the execute. Okay, the read allows you to look inside. It does not allow you to run the file. To run the file, you have to have execute rights, and then to modify or to delete the file, you have to have write. Having said that, in order to modify the file or to delete it, you have to have permissions also on the directory that's holding the file, right? Because we mentioned before that the directory file stores the name for the file. So if you cannot modify the directory, you cannot modify the file either, even though you have explicit rights that will say W for that group, for example. Okay, so it's the security. It's a well-oiled machine, but multiple pieces are working together on it. Okay, you can also use the syntax where you say u equals x. And so then, instead of adding, subtracting, you just specified that one permission that you want this this set to use. So for me, it was user will have executable. You could have said user equals x wr, and that's what would be set for that. Okay. Any questions at this point about the syntax, the rw dash, or what these columns mean? Any doubt? Yes.
So you can have it so they can't read or write the file, but they can execute the file itself.
Yeah, so that's tricky, and that would not work, right? So you have to have read permissions and execute permissions in order to do something with a file. Yeah. Yep. Yep, so there's all kinds of combinations, but some of them, you're right, they will not work. You can, though, write to the file without reading it. That's pretty neat. Okay, you basically can say echo redirect into a file, and it will work. You can read to the file. Well, the reading of it would not be so good. You don't see those kinds of crazy settings very often, because if these are files under my directory, most of the time, if I am sharing the files, it's going to mean adding read access for the other groups, or maybe manipulating the group permissions so that they can read. But yeah, other things are possible, other combinations, yeah. All right. All right, so at this point, we have this figured out. Let's talk about then another way that we can work with these files, which is totally geek. Okay, it's going to do with bits. Okay, with bits. And so the way we do that is we have three positions here. We have the first three sets, the second three sets, and the third three. And each one is represented by a number. So if I say chmod 0000 on my.zip, I effectively took all the rights away from everybody. I said 0 for the user, 0 for the group, 0 for the owner. Now what would happen if I was to say 1, 2, and 4, which, by the way, right, if you look at patterns, what do these numbers have in common, 1, 2, and 4? Binary, yeah. Powers of 2, right? 2 to the 0 power, 2 to the to first and the second. So when I do that, okay, this is the syntax in setting the execute. So execute is number 1 in decimal representation. It's basically the first bit. Then write has a value of 2, then read value of 4. If you would like to give all the rights in the first position, then you use number 7, because 1 plus 2 plus 4 is 7. Okay? 7 means all the rights. So if I was to give myself a 7, I'll give myself a 7 and leave 2 and 4 in the other positions. Then I have read, write, and execute because of the 7, and then write because of the 2, and read because of the 4. Okay? What if I wanted for others to see the R and the X? The R and the X only. 5. Excellent. 5. So what I have to do here is I have to take the 4, which is read, and I have to add execute, which is 1. Okay? And the way this works is when you write down 0, 1, 0, 1, 0, 1, then each position is a power of 2. And basically, when you say 1, 2, 4, you're able to manage those bits in decimal systems. So that's how we come up with a 7. It's then the total of 1, 2, and 4. So if you wanted to have 655 on the file, which is fairly common. I'm sorry, not 655. Yeah, maybe like 755. So basically, the owner would have read, write, and execute. So all the rights, and then others might be able to read and execute, Comment on a directory, because we would manage the directory, and others can go in and read and then use the files in the directory. Does that make sense?
Yeah.
Okay, so it's sort of interesting, you know, and it works. And again, it's sort of the geek thing to do. And administrators that work with the system every day, they love this because it's a great shortcut. Very quickly, you can set the permissions you want. If you don't use it very often, you probably will prefer the W plus syntax because it's just more intuitive, more logical. You actually see what it is you're giving. This may take a try or two, you know, to get the right permissions set. All right. At this point, what I want to do is let's take about 5 minutes of break. Stretch your legs. After this, we're going to look at special permissions. Okay. If you thought that any of this was crazy, the special permissions are really nuts. And when you come back after the 5 minutes of break, go ahead and Google special permissions. Maybe look in the textbook. There is a part of the chapter on it, and try to read up on it. See if you can get some background. Because in my experience, it takes 2 or 3 times to get the special permissions explained. Okay, so if you read a couple of tutorials online, it'll give you a couple of perspectives, and then we'll go over it again together. So 5 minutes of break, 5 to 10 minutes of the research on special permissions, and then we'll resume after that. Okay, so let's go ahead and talk about special permissions. And is anybody willing to perhaps give us an overview or a scenario when a special permission would be used? You know, why do we have the special permissions? What do they do that the non-special permissions, the normal, the day-to-day permissions don't allow?
People usually still like that on executed and stuff, but then only the person actually, only the owner of it can actually delete the file.
Okay, yeah. So we're talking about the sticky permission. So it's one of the 3, the sticky bit permission that it allows on the folder to create the environment when only the owner of the file, even though everybody has read and write, only the owner of the file can read it or delete it. Okay? So the first thing that we learned about sticky permissions, special permissions, is that they behave differently when they are set on files or on folders. All of them have a very specific use. Okay, so it's not general like, this file is going to be read, write, or execute. It's going to be a special situation. So I'm going to draw up a little chart, which I later on will show on the computer. But basically, we will start with files, and then we'll have directories. Okay, and so this last set is going to be sticky. It's called a sticky bit, basically. And when it is put on a directory, right, when it's put on a directory, then it allows us to read and delete files when they're only ours. What directory do you think would have a need to do that? What would be the scenario when you would use the sticky bit on a directory? Any directory that's shared and everybody has to write to, but it's sort of important that those files are still private. A short directory starts with the letter T, and it has files that are quickly created and temporary. Excellent. So if you look at our FHS and we go to look at the TMP, the temp directory, notice that it has a T at the end, a T. Okay, and it means it's a special permission. So I'm going to add TMP here as the scenario when on a folder or a directory you would use a temporary permission, sticky bit permission. So in a TMP folder, it's important that all kinds of users write to it, but that they cannot see the data or delete it, mess with it for some reason. Root can go in and say remove all temporary files, and it, programs will break and other things does happen when that happens. Yes.
Is that a difference in Unix or Linux than over Windows? Windows pretty much any user can remove those files, right?
The big difference between Unix and Windows is this: in Windows, when a file is in use, nobody can remove it, which is why it's a problem with backup on Windows. You try to back up a database that's running, it'll say, I'm sorry, but I can't touch this file. Which is why in Windows now, there are shadow backups, which means that the operating system maintains a copy of the file in some kind of a quantum state of copy so that backups can take advantage of it. On Unix forever, you can, if you root, you can delete the file while I'm reading it. I can have it open with VI, you can delete it on me. Okay? In temp file, you can wipe it clean. That's the big difference. Now, on Windows, again, a temp folder can be cleaned by administrator as long as the file isn't currently opened, right? So you can go in and delete files that are old. But when you are the user on the desktop and you go to delete files, oftentimes it will say, sorry, can't delete that file. You own the file, but you have the file open, therefore it's locked and you cannot be deleted.
Right, yeah, sometimes it'll say remove LOSU, but now...
Exactly. And so in Unix it's different. If you want to delete them, it'll let you.
Now, does this restriction refer to the entire directory or just the files within that directory?
It refers to the directory. So it does not refer to files. So if I go inside of these files, okay, well, this one doesn't have anything. So, well, how about this? How about you tell me which ones have files? Okay, so these right here do not inherit, see, the T. So it's only in the directory, because if you cannot see the parent directory, if you don't have rights to it, then you cannot jump to any deeper directories. So that's why the sticky permission is set just on TMP, but really it secures the rest of the tree that goes from there. Okay, so that's the first scenario, and that's going to be the case with all special permissions, that they have this one scenario when they make perfect sense, okay, which is why they're not used very often in other things. Okay, so let's talk about other scenarios, okay, let's talk about other scenarios. SUID, and by the way, we are on page 165, where we talk about SUID, SGID, and sticky bit. So SUID, or that special permission that's set on the user permissions on the file, okay, simply says this. If root is the owner of a file, root is the owner of the file, and it has that SUID set on it, then any other user that tries to execute this file will run this file with root's permissions. In most other scenarios, when you execute a file, it doesn't matter who owns it, you will run it within your environment, within your permissions. Okay? Here is why it's important to have this workaround. Some programs require networking. They require resources that by default Linux protects against. So if you say ping, you suddenly have to use networking that the regular user does not have access to. Or you might use something like ifconfig, or you might use some, which ifconfig in previous versions was restricted to root. But you will use all kinds of commands. You suddenly need root's permissions to actually do what they need to do. So, as an example, let's see where ping is located. We'll say something like which ping, and then we'll say show me permissions on ping. And now notice that there is an S here in the first position, RWS. Because when you type in ping as your regular user, your rights are suddenly elevated. You execute the ping, command exits, and you're done. So technically, if you would like other users on the system to create new users, you can set the special permission on user add command. And now other users can suddenly execute this with root's permission, as long as root is the owner. So this permission applies to the first column that says root here. It applies to the owner of the file. Okay? So here under file, I'll use ping. Okay. Next, we have SGID, or a special permission, which is set on the group setting. And when special permission is set on the group setting for a file, then when you execute this file is executed with the permissions of the group which are on the file, right? So if I'm executing ping, and it's not the case, but if it said r-x here, if I was to execute ping, I would be executing with the group root permissions, not used as often, okay? If you're going to try to undermine the security, you typically do it with the owner of the file. Okay? But there is the workaround where you can use the group for some special scenario when the group permission gives you access to other resource. Maybe it has access to, maybe you have a custom CP command, copy command, that you copied somewhere else in the bin directory, and you set the ownership of the group to web development on that CP command. So now any user that executes that CP command runs that command with web development as the group. And suddenly we realize that there are folders in some htdocs directory where the website is maintained, and these folders allow the web development group to write. So this single command would allow any user to copy files and to write to those directories. Okay? Again, those are really convoluted scenarios, all right? But there are special permissions for special scenarios. So SGID allows us to execute a file with execute with a group permission. And actually, I don't know, don't remember a scenario where I can give you a command that has that setting on it. So if you find one, let me know. We'll put it onto on this table. Okay, now how about this one, where we have a directory and we set the group special permission? Well, this simply means that when new files are created in this directory, then all these new files will have the group assigned to whatever the group is marked on the directory. Otherwise, you see, when I create new files with my user, and so touch test will create a new file, the group that's default to my user is applied, okay? But if I have a directory where the group is web development, and then I create a new file in web development, it will not apply my group, it'll apply the web development group that's actually set as the owner on that folder, okay? So, so group ownership is defaulted. Okay. Now how about these two empty spots? All right. The textbooks that are very thorough will actually tell you that there are special permissions for these spots. But today, those are not operational. They don't have any meaning. Okay. For example, sticky bit set on a file is supposed to keep the file in memory, or suggest to the kernel to keep the file in memory. That's no longer used. Or the SUID for a directory is supposed to keep the user ownership on the file, and that's also not used. So these, most of the time in current distributions, are empty. Okay, so let's preview this table in a little bit of different edition. Special file permissions. Yep, not the first option. All right. Let's look at this one right here. Yes?
Does Windows have similar functionality or no?
Let me check the title of this class. Windows has, let's just call it different, because in newer versions of Windows Server, there are some huge improvements on everything. I mean, here is how the Unix way of life affects Windows. There's something called not PowerScript. What's that? PowerShell, thank you. Okay, PowerShell in the new editions of Windows. PowerShell is nothing else but the bash shell that basically allows you on Windows to manage the entire operating system through the command line. Now, why would you do that? Wasn't Windows the best thing by clicking on things? And it is, until you consider some of the performance gains if you can drop the entire desktop and run Windows in console mode, or basically it's without any desktop. So you can see Windows appearing more and more like Unix, which is why they needed a very powerful language to operate the system. Now, I don't like to say that, but here's how PowerShell is actually better than Bash. And Bash is not the only shell, so there's other shells that we can compare to. In PowerShell, the great thing that you can do is you can use parameters for commands which are objects and not just strings. Okay? In Bash, so in our Unix operating system, when you provide parameters, you can provide numbers, letters, you say user add, and then you provide the user ID as a string. Well, in PowerShell, it can be an object that you operate. So objects have other properties already inside of them. They have methods that you can use. So it's more like an object-oriented shell. Okay, and that's great. That's great. I mean, it's an improvement over what we have to do in Unix, which oftentimes I have to pass a file as a reference, as the command line. On the command line, I'll say, here's the file, and it has all the users in it. Okay, I do that because in Bash you then have a script that goes and reads the file, and it has very much an object to work with. But PowerShell does allow you then to pass files and resources as an object. So, got to give a plug when when it's due. But that's what we see with Windows Server, partly because in the last few years, Windows Server has always been viewed as a department level server, as maybe server that can run SQL databases that are smaller, right? So when the big business runs mainframes and large Oracle databases, that's typically on the Unix backend. So you can see where the improvements in Windows to be competitive are made that way. In Unix, the bash works, so there's no reason to fix something that works. But who knows? In the future, we might see more improvements. It's very reliable. It does its job, and the biggest improvements that we see today in technology are not necessarily on the environment for the operating system. We want that to be stable. We want that to be very tested, reliable. We see the improvements in the programming languages, like Java, like PHP, in browser-side technologies that allow the developers then to create the applications, the mobile applications and so forth, that the user sees, and you see the benefits. The back end of what environment Apache runs in, what environment Oracle runs in, the idea is let's make it as stable as possible, which is why, again, for decades now, some of the commands have not changed and they work well. So anyway, okay, enough of the comparisons. We all have tools, and we just choose them to do the right job. Okay, looking at special permissions. Now I'm going to have to edit this recording and cut all of this out. No, so special permissions viewed in a different way, right? So it's nice to look at the same topic from a different perspective. But basically, we see that when you set it on the file, then the program will be executed with owner's permissions. Ping is a great example. When it's set on a directory, again, most of the time this is an empty cell in current editions. And so then we have the group. The group can be set on the file, and the group on the file simply means that you'll execute the file with owner's permissions. And when it's on a directory, then all the new files that you set inside of this directory will have the group assignment that was the owner of the directory. The special sticky bit, the program sticks in memory after execution. The kernel today is very, very advanced on how it does caching and how it does performance of software. So there's no reason to make those kinds of suggestions to it. It has algorithms that tell it, when to copy something in memory, when to put it in swap. So in the past, you had very important program on the mainframe that you didn't want to go to swap. So you set a special permission on it. Today the kernel looks at it and goes, yeah. And it just does whatever it's programmed to do, which is very efficient. And then on a directory, any user can create files, so that's a temp directory scenario. So let's see how this works at the setting level. If I'm working with a file, and let's take for a moment maybe my test program. If I was to add the special permission, so I would say chmod u plus s. So now I'm setting the SUID. I'm setting the SUID, and I say go ahead and set it on the test program. Okay. Notice that my program is all red, all unhappy, and then there's a capital S here. Why would that be the case? Why is it like it should be lowercase s? But something isn't groovy. What's wrong? Yeah, if you look on the previous line, it just says RW dash. So it only makes sense to have a special user ID permission if the file is executable. Without the file being executable, it has no reason to be on the file. So it's marked with a capital letter, and it says, hey, something is wrong. So all I have to do is I'll just say add execute to this. And now it's lowercase s. And so now it's working. It's ready to do something. Let me show you what it might look like on my.zip. When I say chmod g plus s, so now I'm adding the special group permission to the file. Notice what happens with my.zip. Did you notice anything out of ordinary? I added the special group permission to my.zip. And what's not right? Yeah, in this position it should read an S, and yet it doesn't. So the reason why it's not showing S is because the group here is root, and my user ID, just the regular user, doesn't have permission to manipulate this group. So it will not add this. If I instead was to run the same command on my test file, then it is manipulating this field because I do have permission to the group. So it's same way if I was to add the execute, it actually is configured properly. Yes. So let's undo this. We'll say chmod zeros on the test. All right, and so now test is like this. And if I go into home and I say show me test, well, it wasn't test, it was my zip. My zip. So now I say show me my.zip, and I can say chmod group add execute, and now the X is here, and I can say chmod group add S to it, the special permission, and now the S is lowercase. So once I have permission to operate this group, then I can add the special permission, because obviously this is going to elevate my privileges. So to do that, to start with, you have to have the privileges to give them away. Okay, and then the sticky bit, if I was to say chmod others, then this is how we would, well, let's see. Oh, I see. So this is not a, I'm assuming it's not an executable file to start with. And so actually let's change that to like this. And if I was to say chmod others at S, all right. It might be a T. Well, that works just about as well. The other way to add these permissions, I think the syntax might be a better approach, is through the numbers. So what I can do is I can say 1 in the front, which stands for the sticky bit. So then there's 1, 2, and a 4 based on the sticky bit group and user. And let's see how this works. Yep. So apparently don't use this syntax. Okay, this in this scenario is not going to work. But if you use the numbers, then the sticky bit will be set just fine. Learn something new every day with Linux. What's that? It worked because I used the numbers. I did too. Am I getting that old? Okay. So here's what we'll do. We'll say, go back here, remove special permission. So we set this to 0, and it's read and execute on all counts here. So we'll say chmod like this. It did work. I'm sorry, what's that?
You were using S before.
S before the T, yeah. They are very special, these permissions. Okay, so so that's I like this table here. You know, it gives you a little bit different view. Finally, a great article on Linux special. No, I think it's just called File System Permissions. And this one right here, where you have a explanation about even the first column, the file types, and going down to the different notations. So nice reference work on that. Okay. All right, great. Give it a little thought. If there are any other questions, we can go over that. In the textbook, I like page 167 and 168 because it gives you a nice graphical view of how the letters from an X become an S, and which sticky bit permission or which special permission belongs where. And then on the next page, you have additionally numbers added so as to be able to quickly figure out, you know, how to add in a numerical expression, read or write or execute, and then the totals. So those are some nice references. Yeah. Okay, I did not go over some of the simple commands of managing directories and files like make, mkdir, or you know, touch. I assume that the 132 class covered that. Okay, and if you, what's that? Refresh. Oh, you need a refresher? Okay, well we can run through a quick refresher. The thing with these commands is that you know, we can talk about them unless you use them a few times, which is why I like the lab connection, because you know it'll give you a little bit hands-on. So if you feel like you need a little bit practice with them, then please take a look at the hands-on projects in the textbook. The hands-on projects, especially in the first part, the 4-1, they talk about and specifically give you examples of how these commands work. So in a fairly quick refresher, okay, starting with a clear slate here, to create a directory, okay, you say mkdir or make directory, and I'll create a directory called temp. Now it's a directory. I know it's a directory because when I look at all the files in the parent directory, then next to temp there's a D, and it's also blue, right? But if you don't have the colors configured, it'll just say temp. But that's how we can tell it's a directory. So when you type in ls-f, okay, you have more visual cues, and so directories have the dashes next to them, and executable files have the stars. Hardly ever you'll use that. Okay, the ls-l by far is the most common way of looking at details on files because it has more information. You can say ls-lt, which is useful because it'll sort the files from the newest, the ones that were modified in the most recent past, down to the oldest ones, -t, okay, so for time. ls-a allows you to see what's called hidden files. Okay, hidden files are for your protection. What you don't see, you can't break. Hidden files, especially directories, are created by specific software that is trying to maintain its settings. So under a GNOME, you're going to have settings for your desktop. Under .mozilla, somewhere here, right here, you have all your Firefox settings, right? So that's a hidden directory, starts with a dot. Hidden files also start with a dot, and oftentimes these files simply mean they have some scripts that are executed while you're logging in or when you log out, but they are supposed to be maintenance files. So -A on ls. Okay, to create a new file, okay, to create a new file, you can use multiple commands. First, let me go inside of my temp directory so that we have fewer files on the screen. CD, change directory, goes inside of temp. Clear will just clear the screen. PWD is going to show us where we are in the current working directory. So touch is a common command. Touch allows you to create a file or refresh its modification date on an existing file. It doesn't recreate it, it just refreshes its modification date. So you edit a file on the fly. That's what touch does. And when you say touch test, it creates a file called test. Another way to create a file is to say, go ahead and display anything. So that's what echo does. And then redirect it into a file. So now I created a file test2, and it so happens that the file test2 has something inside of it which I provided. Okay, so that's how I can create a file. I can create a file by editing it. So let's try the nano editor, and I can say now I'm editing a file. Now Control X to save the file, yes to confirm, enter, and now I have 3 different files. So you can create new files with multiple different commands. Create directories. Now if you want to rename a file, you can say move, MV, move test3 to test4. Notice that when you execute Unix commands, there's no message that this was successfully completed. So you have to be satisfied with no errors, right? If something goes wrong, there's an error. For example, if I was to try to rerun this command again, there's an error. And so when this executes properly, there's no error, and that's the good feeling. So that's as good as it gets. Move. CP is another command which allows you to copy a file into a new file. That's the CP command. RM is a command that allows you to remove a file. Okay, remove a file. So move or rename could be done in this. I can say test or copy test to test7, and by the way, remove the original. So the copy and then RM would do the same what move does. Basically rename. Now move, actually, it's not that simple. Move does it a little bit differently, because when you say move, it actually just renames in the directory file its name. So the settings are the same, security is the same. Okay? Whereas copy physically makes a new copy, provides a new settings, new default permissions on it. So when you remove the original, you're not duplicating exactly perhaps what was on the original. So move is slightly different than just copy and remove. Okay, I did use chmod earlier today. So chmod would be to set permissions on the file. umask is something that we should mention. Umask is a command which would help you set the defaults that every new file would have. So when I created these test files, all their security settings are the same: read, write, and read. And that's what umask specifies. Umask basically says which permissions should be removed from which setting. So if you have umask set to 000, then new files will be created with 777 permissions. Okay, so that's a UMask, and you shouldn't modify that setting. Most software installation programs sort of rely on the UMask to be the default. Okay, so a couple of other commands. Change group, CHGRP or change group, and I have to be root for this. But basically, change group allows me to say change group on test, change group to root on test 2. So now I've modified the group ownership on a specific file, change group. The other thing you can do is you can say change owner, chown, and let's put root right here. And so now I change the owner that's on the file with chown. There's another command I want to show you, but let's see. I don't use this command very often. Group. It's to change your current group. If you are in multiple groups, you can modify your default group that will be set on files from now on forward. It's group switch or let's Google that. Change default group. By the way, if you go to Google and you say Google/Linux, that used to be the case. Well, never mind. There used to be a whole like Linux Google wrapping, but that's changed. Okay, Linux change current group. New group, there we go. So new group, and then if I specify a group, if I from now on create a file, okay, you can see that the group is now whatever I specified as my new group. Otherwise, it should say root, because root is the user. So new group basically gives you a little bit what the special group ID would be on the folder, which is basically ability to create new files with a different permission. All right, any questions? Yes, question. No, this is for the current session. If I log off as root, it's all gone. Yep, for the current session, yeah. All right, good deal. Well, thank you very much again for your patience, for not falling asleep, and for your discussion. If you feel like you need a little bit of refresher on the commands, please look at those hands-on projects. They do run you. You don't have the book? Okay. Well, we'll use my book. I'm not going to use it, so it's being shipped. Oh, good. Well, now, okay, never mind. Good deal. So just when you have two, then bring one back. Okay, so I'll see you next week. Next week we'll continue to look at file systems, and that's all for tonight.